Good morning everyone. In this lecture, we will learn the geometrical construction for the engineering course. In first year syllabus, we have basic three types of curves. The first one is the involute, second is the cycloid, and third is the helix. So we will discuss all three types of curves one by one. So refer the first curve, which is the involute. So the definition is, it is defined as the curve traced by an end of a string when the string is wound or unwound around a circle or a polygon, keeping the string always tight. So let us see the physical process how the involute curve is generated by the end point of a string. So here I have taken the polygon, which is the perfect square, and if I take one piece of a string, so this string, it is having the length which is equal to the perimeter. So right now perimeter for the square is 4 into side. If we attach one end at this corner, at the corner of the polygon, and the second end, if we keep the string always tight, and if I try to wound the string like this, keeping the string always tight, then the second end point of the string, it will trace out one curve. So that curve generated, this is called as the involute curve. So here I have attached the pencil at the other end, so we can see the curve traced by the second end point. So one end is fixed at this corner, and the length of the string, it is equal to the perimeter, that is equal to 4 into a. So you can see the curve which is traced by the end of a string. So this curve which is traced by the one end of a string when the string is always tight, this is called as the involute curve. So we can generate this involute curve for all polygons and even for the circle. So similar to the polygon, if I take the circular disc and if I attach the string, one end is attached with the circumference, we can take the length which is equal to the perimeter, and then if you try to wound the string like this, so it will generate one smooth curve. So this smooth curve, it is called as the involute curve. Okay. Okay, so let us see the problem on the involute curve. So here first problem given, draw the involute of a square of side 20 mm and also draw the tangent and normal through any point on the curve. So the given geometry is the square. So first step is we should draw the square with the given dimension. Next step is we want to develop the involute curve for the given square of side 20 mm. Okay. So from point 1, draw one horizontal line, and on this line take the distance which is equal to the perimeter. So right now perimeter is 4 into a, which is the 4 into side. So as side is 20 mm, so take the distance 80 mm. So this is equal to 4 into a, which is equal to 80 mm. So basically this 80 mm, it is nothing but we have taken one string like this. Okay. So second end point, its distance, it is equal to the perimeter, and then we will imagine we are just moving this point and it will trace out one curve. Okay, so you can name this point as a P1. So this is the starting point of the involute curve. Now from each side, draw one horizontal line. Draw one line. So side 1, 2, side 2, 3, side 3, 4, so when we take the square, and if this point is fixed, we have attached the string at this corner. So this is the initial radius for the involute curve. Okay. So this radius, it will remain same till this point. Okay, till this second corner. After this corner, the radius will change. So this is the radius. Okay. So after quarter revolution, in case of square, we have to change the radius. Okay, and distance will reduce, which is equal to the side of the polygon. So first take 1 as a center, and the radius is equal to the perimeter, which is 4a, and draw the arc like this. Okay. So for this region, the center point is 1, and this is the radius, which is equal to the perimeter. After this point, take this point as a P2. The radius will change and even the center point will change. So we should take the 2 as a center point. Take this radius. So distance 2 to P2, and from this point